So in this video I'm going to take you through the ChiSquare. If you struggled with this a little bit last week by looking it up in the book, then hopefully this will make things a little bit clearer for you. So when do you use ChiSquare? Well, first and probably most importantly, it's when you use the nominal level of measurement. So in other words, your data is in categories. Secondly, each participant fits into one category and one category only. And thirdly, it's when you're testing for a difference between two or more nominal variables. So for example, does gender, male, female, affect the type of holiday people prefer? So adventure or beach. And those are nominal data. So let's have a look at our example in a bit more detail. So I'm going to bring in a table. You can see it's got headings and it's got some data in the middle. Now, one thing to be really aware of is that this is known as a 2x2 table. There are 2 rows and 2 columns, and notice I'm ignoring the labels. So I'm ignoring male, female, adventure holiday, beach holiday. And as you can see there, that is the data section. Okay, I'm just going to review when to use ChiSquare. I know we've done this already, but people always struggle with this one, so I'm going to do it again. So number 1, when you have nominal level data. Nominal data is categorical data. So 23 male, 34 female. Each participant can only fall into one category. So vegetarian, meat eater, or vegan. And it's also used when you're testing for a difference between 2 or more variables that are nominal. So is there a difference between birth order and career choice? Or do women tend to drive different types of car to men? And those are nominal variables. So before we get going, here's a big fat friendly tip. Chi-squared is the only test in this A-level that uses nominal data. The other 3, Spearman, Mann-Whitney, Wilcoxon, they all use ordinal and or interval data. Okay, let's have a look at performing a chi-squared, and we're going to do it in 5 easy steps. The example is going to use a two-tailed hypothesis. Does taking medication impact the number of days a cold lasts? Okay, let's go through it with step 1. So this is creating something called a contingency table, which is a posh word for something that's actually fairly straightforward. All it means is put the data into a table with, first of all, your totals, and secondly, your grand total. So let's have a look at that. There we go. So here we've got our totals and our grand total. And what I'm just drawing here is the actual data bit. This is still a 2x2 because you've got 4 elements of data. Yes, 1 to 3 days, no, 1 to 3 days, yes, 4 to 7 days, no, 4 to 7 days. This data is known as your observed values. So it's important to see this as a 2 by 2 and not to get fooled by the fact that with a contingency table, what you'll have is you'll have the totals and the grand totals surrounding it. So you've met observed values before. These are always the values that you calculate in your statistics. However, you haven't met something called an expected value. So the values you see in your table are, as you know, called the observed values. But you also need to calculate something called the expected values. And in the simplest way to put it is that the expected values are those that you would have got by pure chance. So if everything was purely distributed by chance, this is what the table will probably have looked at. So let's have a look at step 2. We've got our contingency, and now we need to calculate these expected values, those that would have happened by pure chance. And there's a fairly easy formula for this. An expected value is the row total times the column total divided by the grand total. And you have to do that for each cell in the 2 by 2 table. So let's have a look at this. Here's my observed values. And hopefully here are my expected values. And I've done the first 2, so hopefully you can see how those have fitted together. What I strongly suggest you do is you pause the video here, have a go at working out the final 2 e-values and put them into the table just to make sure you're happy with that skill. Okay, so here are my answers to step 2. Just pause the video here, just check you're happy with how those fitted together. Just make sure you've got the same thing. Okay, step 3. This is where you've actually got to do the chi-square calculation itself. You're given this equation in the exam. Here it is. It looks horrible, but actually let's break it down into a step-by-step process. Remember that funny sigma, that funny symbol looks like it is a sum symbol. So add things up. And here's our table. We're going to break this down. O minus E, first of all, we're going to do that for each one. Then we're going to multiply that up. We're going to square those up so that we get rid of any negatives. And then we divide each one of those O by minus E squareds by E. Don't worry about any repeated values. And to get your final value of chi-squared, just add up everything in the last column. Again, pause the video and have a go. In a moment, I'll show you my answer. So here's my answer to step 3, so actually working out the chi-squared itself. Pause it here, just make sure you've got the same thing that I have. Make sure you've ended up with the same chi-squared. A bit of a tip here, chi-squared often gives you repeated values in the table. That's completely normal. I've got them here, don't panic if you see that. So step 4, we're actually going to calculate something called, strangely, degrees of freedom. In the previous tests you've done, you've had to use the number of participants in this study to work out and find significance, to find a critical value. In chi-squared, you do something slightly different. What we use is we use the size of the table, and that results in this weird thing, degrees of freedom. So I want you to focus just on the data bit of that contingency table, the bit I highlighted for you. This was a 2 by 2 table in our example, 2 columns, 2 rows. Degrees of freedom is a really easy formula. Number of rows minus 1 times number of columns minus 1. And in our case, it's 1 times 1, which is 1. For a 2 by 2 table, the degrees of freedom, notice it's called DF for short, is always 1. For a 3 by 2 table, the degrees of freedom always works out to 2. Okay, step 5. Is chi-squared actually significant? So can we work out whether this test has actually given us a significant result? Well, we need to know several bits of information. First of all, are we going for a 1 or a 2-tailed test? So in other words, are you predicting a difference or are you going to give it a direction? Second thing you need to know is the degrees of freedom. We need to know our significance level, and usually that's p less than or equal to 0.05, so 5% level. And we need to know our observed chi-square. So in the example that I've been walking you through, what have we got? We've got a 2-tailed test. So we're just going to predict there's a difference. Our degrees of freedom is, well, it's a 2 by 2 table, so it's going to be 1. Our significance level is going to be p less than 0.05. We just take the standard one in psychology. And our observed value of chi-squared is equal to 84.49. So we've got everything we need here to look things up. So that's actually complete step 5. So what we can now do is actually use this chi-squared critical value to work out significance. So this is what you'll get in the exam. This is the information you'll get, the chi-squared table, chi-squared formula, and the degrees of freedom. And what you've got here is we've got this idea that if we look for a 2-tailed test, p 0.05, we look for degrees of freedom 1, and we find 3.84. Now, the reason that you're seeing those rulers is because I like to do it this way. I like to make sure that I know which one I'm doing. And then what I like to do is to highlight it. You can also see that because our observed value is greater than the critical value, we can accept the alternative and reject the null. The results are significant, and therefore there's a significant difference between taking or not taking the medicine and the length of time a cold lasts. And that's our final conclusion. So some top tips for the chi-square. This is the only test that uses the nominal level of measurement. Each participant belongs to one group, category, cell, whatever you want to call it, only, but they only belong to one of them. It's a difference test. The observed value of chi must be greater than the critical value of chi to get significance. And one thing that people forget, the data in each cell are frequencies, they are not percentages. Okay, so let's go through a summary of the main steps in our chi-squared test. So those 5 steps I've taken you through. Step 1, you create the contingency table with its totals, subtotals, and grand total. Here's the example you used, and I'm just going to highlight those totals there. And the grand total at the bottom there. Number 2, you need to calculate the expected values. Now this is really annoying because they don't give you the formula in the exam, so it's something you need to learn and remember off by heart. Here it is. Number 3, this is where you calculate chi-squared using the formula itself, and they do give you this one, and then the step-by-step table, which again they will pretty much always guaranteed give you, but not necessarily. Here we are. That's the example you did. Number 4, you're going to calculate the degrees of freedom. Well, in this case, it's a 2x2 table. Number 5, you're going to look up the critical value of chi using the degrees of freedom, the significance level, the type of tail 1 or 2, and the test is statistically significant if the observed value of chi is greater than or equal to the critical value. If you're still stuck, go back through the video, pause on the bits you need to pause, but apart from that, thank you very much.